Hi, we are engineering brothers, and once again we have got our another interesting classes over here. In our previous analysis, we have given you much needed example for our stability with a simple examples over there. On our previous two videos, we have described our much needed consideration for our example and how do we say that the stability factor is very important for our any given system over here, specifically for our control system or our considered part. In this present class, we are trying to focus on our stability of the linear time invariant system. I have already told you what is the exact definition of our linear time invariant system, which is the parameter value or the system do itself not being considered as a changeable parameter over here. Suppose we are having our LTS system, and if there are some coefficients of say A0, A1 are present over there, and if the system time is changes over there, and if the A0, A1 these values are not changing according with our time, then we can say that we are having a linear time invariant system over here. Now this is the simplest definition for our linear time invariant system, and for our control system, specifically for our definition of our transfer function or any type of consideration, we are having our system as our linear time invariant system. Now this is our first step for considered part. And what is the stability? The stability is the most important parameter for any type of system over there, specifically for our time invariant system over here. And I have described simply about the definition of our linear time invariant system. The coefficients of that system is not changing with respect to time. Okay. Now the stability is the most important parameter over here, and quite naturally the CT, which is the response for our given system, that is being considered into two parts. The first one will be our CT forced, and the second one will be quite naturally our CT natural. The response of our given system do have these two type of consist of actually two type of considered response over here. The first one will be our CT forced, and the second one will be our CT natural. And our in this class or in this chapter, the CT natural is the most important factor for our given considered part over here, because we can't have the CT forced controlled over here. We cannot control this CT forced over there, and according to the nature of our natural response for our given system, we can conclude that whether the system is stable or unstable over there. And if we say that the CT consists of two important considerations over there, the first one is our the CT forced plus CT natural, and according to the CT natural, we can define or we can say that whether the system is stable or unstable or marginally stable, whatever may be the conditions over there. I have already told you about our previous consideration, what is the definition of our stable, unstable and marginally stable considerations over there, and with the help of our much needed example we have described in our previous videos. If you have missed our previous videos, please do follow our previous videos. Now, quite naturally, we are having our three important waveforms over here, and quite naturally you can say that we can have this considered part as we can control this output of our given system and the CT natural over there. Now, if you are taking that the CT net, the response of our given system is directly dependent on this CT natural over here, and if the response the CT natural is that the value of this is actually tends to 0, which actually refer to our first waveform over there. And if you say that if the CT natural is tends to 0 and that actually bring us that time tends to infinity, you can see that if we do increase the time, the waveform is approaching towards our 0 or towards our 0 consideration over there. We can say that the system is quite naturally stable. Why? Because we can predict the output waveform over there, the response over here, we can predict that, and because of this prediction, or we can say that the output probably this one. Because of this nature of this predictability, we can say that the system is stable. Now in our next consideration, once again, if in this given system or in this waveform, you can say that the CT natural is not actually tends to 0. It is actually tends to some say the unbounded output. If we do increase the time, that actually bring us t tends to infinity. Now if you just do increase the time over here, or t tends to infinity, we are having that the output response in this system will be unbounded, or we cannot predict the output waveform of our given system. If you just do increase the time, we cannot predict the output of our considered part over here. We can say that in this case, for our waveform 2, we can say that the system is unstable. This is going to be, the system will be unstable. And for the last one, once again, if you just do increase the time, which is t tends to infinity, the output value CT natural, that value will be for our initial part it is increasing, and after some time that is decreasing. So it is been decaying, or increasing, the both type of characteristic over there. And if you just say sometimes it is decreasing and sometimes it is increasing. Because of these two opposing nature of our decreasing and increasing nature over here, we can say that the system itself is quite naturally or marginally stable over here. This considered waveform actually do give us that this is going to be our marginally stable over here. And quite naturally we can say that according to the response of our given system, we can predict the output of our given system. And how do I say that whether the system is stable or not? That is being described by me with the help of these two waveforms over there. I want to repeat this portion once again, because this portion is very, very vital for our stability considered point over here. Because if you just don't say that whether the system is stable or not, you are not been able to understand the characteristic of that given systems over there. And the first of all, for the fast response, if we just do like to increase the time towards infinity, the output tends to 0. You can see that according to the waveform or according to the diagram, you can see that if you just do increase the time, the output tends to 0. That actually gives us the predictability of this waveform, and we can say that the system is stable. Now move on towards our next waveform. In this case, if you just do increase the time t tends to infinity, we are having our unbounded output over here, because after if you just do increase the time, you can say that, or you can see that we are having our unbounded output over here, and it is been oscillation, or the waveform of our oscillation will be realized over here. And we can say that the system is unstable. Why? Because we are having our unbounded output over here, and in our precise sense we can't predict the output for this given system. Now move on towards our last considered part. You can see that if you do increase the time, for some time the CT value is increasing up to this one, the waveform is increasing, and after some time it is decreasing. So increasing, decreasing, as we are having these two considered part over here. First of all, for our stable system the waveform is decreasing. For the second one it is increasing, or to have the oscillation in this given waveform. But if you just do add up these two considered concepts over here, and we are having the system is in the marginally stable consideration. It is not stable, it is not unstable. In between these two considered part, we are having our marginally stable over here, which is for our decreasing, increasing, both the characteristic are added up at this output from over here. That is why we can say that the system is quite naturally marginally stable over here. So this is the first part for our stability considered part over here. Before I start considering our Routh array or many other interesting concepts over there, this type of logical considerations are very important for our considered part over here. Stay tuned to the classes, do follow our videos. And I would like to say that do follow our classes, do like, do share our videos, do subscribe our channel if you would like to connect with us, because in the future you do feel that our classes will be one of the greatest for our future course of our considered part, and only engineering brother can do that or do this type of depth analysis over here. Stay tuned with our classes to follow our videos. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.